In this video, you'll learn how to size elements in CSS based on the dimensions of the parent element. Let's go. Hey, welcome to a new Tuts Plus tutorial. If we're just meeting, my name is Adi Purdila. I'm a web designer, and my goal with these videos is to help you become a better web designer and developer. Now, recently I published this course about CSS container queries. It's free and you can find it on Tuts Plus. In that course, I talked about the power of container queries and how you can use them to create responsive components without using media queries. If you're not familiar with the topic, then go ahead and check out the course first and then come back to this video. Now, something I did not mention in that course is container query units. So before we dive in, let me give you a bit of context. In CSS, we have a lot of units we can use to size elements in various ways. For example, we can use pixel, em, rem, and so on. We also have viewport units. These are directly related to the viewport size. So in this example, the font gets bigger or smaller as the viewport gets bigger or smaller because we used the VW or viewport width unit to make that font size dynamic. Now, container query units, or we can just call them query units for in short, are very similar to viewport units with one big difference. While the viewport units are directly related to the size of the viewport, query units are directly related to the size of the parent container, not the viewport. Okay? So, in this example, the font size is also dynamic, but it gets bigger or smaller depending on the width of the parent element, not the viewport. See how the viewport size stays the same? I'm only changing the size of the parent of the text element that uses query units. That's pretty awesome. Now, just like container queries, these query units are also experimental. And at the time of this recording, which is November 2021, they are only available, or they're only supported by Chrome Canary, and that's under a flag. I'm going to show you how to enable the flag in just a little bit. But I have a strong feeling that both container queries and query units will become widely adopted by all major browsers in a relatively short time. So we might as well just start learning about them right now. So let me show you how you can use these query units and which ones you can use right now. But before we do that, here's a quick message from Envato Elements. With one subscription, you'll have unlimited access to WordPress themes and plugins, web and email templates, Bootstrap templates, and more. There are millions of digital assets to choose from. They have simple commercial licensing, and you can cancel anytime. Subscribe now using the link in the video description. All right, let's talk query units. Let's begin by looking at the official spec for these query units, which right here, they are called container query length units. We have QW, just never mind the C letter here. The official or the notation that is currently supported in the browser is QW. So QW is 1% of a query container's width. QH is 1% of the container's height. QI is 1% of a query container's inline size. This is very important. QB is 1% of the block size. So now inline size, block size, if you're not familiar with these terms, they basically speak to logical properties that are used in to position and align elements in websites that are maybe written in a different language, right to left languages that have the direction of the text different than the traditional left to right, or maybe languages that are written vertically like Chinese or Japanese. So if you're interested in that, make sure to check out Tuts Plus. We have a course all about logical properties that will explain this in more detail. But for now, just know that inline size, block size, you should really use these instead of width or height, because it's just going to make your job easier in the long run. But these refer to the logical side of aligning and positioning elements. And then finally, the two other values we can use, or the units we can use, are Qmin and Qmax. Qmin represents the smaller value of Qi or Qb, and Qmax is the larger value of these two. All right, so now that we know what query units are available, let's see how we can implement them in a simple demo. So I've prepared a simple demo for you right here. We basically have a list of articles that have an image placeholder and an article content, and they're displayed using CSS grid layout. I'm also using container queries here to demonstrate how you can achieve different variations of an element based on the size of the parent element. So right here, I have set the container to inline size on the actual articles. So the article is the parent element. And you'll see that depending on the width of the actual article, these cards are displayed differently. If the article is shorter in length, it's displayed like this with the image above, text underneath. If we have more room, so if the article is bigger than a specific value, in my case, bigger than 20 rems, then I'm displaying the article like this. Image on the left, text on the right. And also the text here is bigger. And if I have enough room, like in this top example, when the article has a minimum width of 40 rems, then I'm displaying it like this, with the image as a background and text aligned to the center and much bigger than the other two options. All right, so this is a typical example of working with container queries. Now, as you see, I am using Chrome Canary here, and to enable container queries and query units, you need to go to Chrome, Flags, and then search for CSS container queries. As you can see, mine is enabled, so make sure you do that as well. Otherwise, you won't be able to see this. So let's take a closer look at the code here to understand what's happening. And I'm only going to focus on the stuff that concerns us right now. So we start with the article card. This is the small size, the default. I have a padding of 1 rem, a gap of 1 rem because I'm displaying items in a flex container. And then the H1 has a font size of 18 pixels, like this. And then for the medium, these two variations, I'm changing the padding on the article card to 1.5. I'm doing the same thing for the gap. And then I'm changing the font size of the H1 and paragraph to 24 and 18 pixels. So notice the H1 and paragraph are larger on this version of the component. Finally, on this top component, we have the large version. Here, I'm just changing the padding because I don't have a flex container anymore. And I'm changing the font size of the H1 and paragraph again to 52 and 24 pixels. By doing this, these elements will start responding to the size of their parent containers, right? So you will see that as I'm shrinking this page, the elements will shrink alongside with it. And once they reach see? Once they reach specific widths, they'll be displayed one way or the other. So see these two elements here, which were previously using the medium style, are now using the default style with the image on top. This one, as I'm shrinking, will go to the medium style as well. And if I just keep on making this smaller, shorter and shorter, you'll see that these will start going on one column. They will change their style to medium because they have a minimum width of 20 rems. And I can just keep going and they'll change their style to the default. So that's the power of container queries. Now, how can we apply query units to this demo to make it even better? Well, I've made a copy here. It's exactly the same code as this pen here. And by the way, you can find links to everything down below. And what I'm going to do is start with the article card in its default state, right? I'm going to start with the padding and gap. So this changes. It's 1 rem on the default state, 1.5 medium, and then 2 rems on the large. But here's what we can do. Instead of 1 rem, we can say padding 5 QI. That's 5% of the container's inline size. I can also do QW, but in this particular case, the width is basically equal to the inline size because of the way writing direction is set up. So I'm going to keep using QI. This means that the padding in this article card is basically 5% of the parent's width. And you'll see that as I'm making it bigger, that padding will change as well. When I make it shorter, that padding gets shorter. I can say I want this to be 50 QI, right? So in that case, we're going to have like a huge padding, which you can see right here. But just in case I don't want these padding values to go under or above certain values, I can do this. I'm going to use the clamp CSS function, and I'm going to say the minimum is 1 rem, 5 QI as the currently running value, and the maximum should be 2 rems, like so. This is a really cool function, clamp. So again, it basically says use the value of 5 QI, but don't go below 1 rem or above 2 rems. So now, as I'm resizing these elements, the padding will stay within those boundaries, but also be calculated directly based on the width of the parent element, which is pretty cool. So by doing this here means that I can delete this, I can delete this, and I can delete this. So now you can see that we still have a padding, but that padding is now dynamic, right? It changes based on the width of the parent element, which is really cool. I can do the same for the grid gap right here. So instead of 1 rem, I can say, for example, 1 Q min. Now, if we're going to do a quick inspection here on the elements, let's make these smaller. And we choose article card here. We're going to go to computed, and we can see that the row gap is set to 2.78 pixels. The width of our parent element is 276. It's actually 278 because we also have the two 1-pixel borders. So 278. 1% of 278 is 2.78. Exactly the value of the row gap, or the column gap for that matter. So qmin currently gives us the inline size of this element, because as calculated by the browser, that is the smaller one. However, from testing, I discovered that that's not exactly true, because if we look closely, this element has a width of 278 and a height of 275. So the width is actually higher or bigger than the height. So qmin in this particular instance should give me the height instead of the width. I don't know what it is. Maybe it's a bug. As I was saying, this feature is still experimental. Or maybe I'm just not using it properly, but there isn't really enough information about it right now to give you a straight answer. So while qmin and qmax are available at this point, you should probably stick with the other 4 units that I mentioned. But just for the sake of this demo, I'm going to use qmin for the gap. And it's very interesting because you can do something like this. You can also use a clamp function. You can start at 1 rem as the minimum, 2 rem as the maximum, and then in between, you can do something like calc. This is another CSS function. You can say 1 rem plus 1 qmin. So basically, the gap here will now be 1 rem, which is 16 pixels, plus 1 qmin, or 1% of the container's width as it's calculated by the browser. And that gives us 18.78 pixels. And now what I can do is remove the gap from here, from the medium size. We don't need a gap on the large. And the result is that the gap between elements will now be directly linked, see, to the width of their parent element, which is pretty cool. Now, let's also use query units for the font sizes on the H1 and paragraphs. So the H1 goes from 18 pixels on small to 24 on medium to 52 on large. So what we can do here is the following. Font size will be equal to clamp 18 pixels. I'll also do a calc here. I'm going to say 0.5 rems plus 4 qi, and the maximum is 52 pixels, was it? So now by doing this, I can get rid of this. And I can get rid of this. I can do the same for the paragraph. All right, so paragraph, font size, clamp. So the paragraph starts at the default 16 pixels, 1 rem. Let's make this calc 0.5 rems plus, let's say, 2 qi. And it goes all the way to 24 pixels. So now I can go ahead and delete this declaration from here and this declaration from here. And I can also simplify the code by adding the paragraph here. And now you'll see that as I'm resizing the viewport, my articles will automatically resize as well. And along with that, everything that I've used query units for, so padding, grid gap, and font size, will automatically resize as well. How cool is that? So notice the text just getting smaller and smaller until it reaches, of course, the minimum size. And then I can go the other way as well until the text reaches, of course, its maximum size. Pretty cool, right? And besides achieving this great behavior, honestly, for the elements, we also reduced a little bit of the amount of CSS we have written. So in this new version with query units, we are at 105 lines of code. And in the old version, we are at 118. So 13 lines of CSS code less in the example with query units. Now, after seeing this demo and understanding what this is all about, you might ask yourself, okay, what happens if I don't have a container defined and I'm still using container query units? Well, it's simple. The browser will then interpret those query units as viewport units. So if you don't have a container defined, then the browser will simply treat container query units as viewport units. And those elements will be sized according to the size of the viewport. Cool? All right. Now let's see some key takeaways. Query units are similar to viewport units. Query units relate to the dimensions of the parent container, not the viewport. Use the CSS clamp function to set min-max values for properties. If no container is defined, query units are interpreted as viewport units. Query units are still experimental at this point, but should be widely available in the near future. And that's how you can use container query units to size elements in CSS based on the size of the parent container. What do you think about this new feature in CSS? Will you be using it once it's properly supported by all major browsers? Let us know down below. With that said, thank you very much for watching, and until next time, take care.